Yeah.
Good. Okay. Enthalpy plus C1 squared over 2000 plus heat added, because no height has been mentioned. So we are not going to take height into consideration. Is that okay?
Yes, sir.
Yes.
Okay. So plus heat, we should give us H2 plus weight. Now, what is H1? H1 enthalpy is given by internal energy plus pressure multiplied by specific volume.
Specific volume.
So in this equation, there is no U. So what would be H1? 50
30
plus 30 multiplied by
1.11.
this should give us 83.3 kilojoules per kg.
Sir, sir,
yes.
I've seen some cases. So since we have enthalpies in kilojoules, are we not supposed to divide by 1,000? Or
But the 30 is also in kilopascals. Yes or no?
yes.
So everything is in kilo at the end of it.
Okay, right. Sir.
So since you like suffering, you are going to say this is 50,000 plus
No.
30,000 multiplied by 1.11. The answer will be 83,300. Then again you convert. Okay? And that's the reason why some of you get very tired when you are leaving the exam. You are very tired, confused. Because they are bringing too many unnecessary things. This is not engineering science where you are taught that to convert the units. This is applied thermodynamics. We assume now you are already sharp enough to know that here I need to convert, here is not necessary. Okay? Are we together?
Yes, sir.
But I like your questions. Keep on asking so that you understand why I'm doing what I'm doing. Okay? I want you to do the shortest possible way so that when you go in an exam, at least you don't get it. That's why some people, just 2 questions, they are tired. They can't try it again. We proceed. H2. So we had 80 internal energy. Was it 80?
Yes, sir.
And the pressure was also 80. Hello?
Yes, sir.
The pressure was also
70.
80. Or 70.
70.
The pressure is 70, right?
Yes, sir.
70 times 2.15.
And specific volume was 2.15.
When you patch this, what are you getting?
We are getting 230.5 kilojoules per kg.
230.5. So, gentlemen, I can actually tell you that in this question, they always play with your mind. Yes, sir. Bruno Kwanji. Yeah, it's just in the next 20 minutes. Okay, thanks. So here, the issue is whether negative or positive. But in most cases, issues are here. This is where people miss the question. I'm sure you have seen. In the first one, they just say D, there is reduction. In this one, no one talked about the enthalpy. It was up to you to find the enthalpy. Now that we know the enthalpy, let us put it in. We are going to have 83.3 plus, what was the velocity at entry?
100 meters per second.
Squared over 2000. Plus Q was what?
60 kilojoules per kg.
Okay, we come to H2. 230.5 plus velocity at exit.
120 squared.
Panchkizo.
$148.3.
Okay, the other side 237.7.
237.5. Yes. Now, is it possible to have a negative weight?
Ati?
Negative weight.
It's possible to have negative heat. It's also possible to have negative weight. Yes. Negative weight simply means that work was being done from the surrounding onto the system.
Yeah, I remember that, sir.
Thank you. And this is where people mark themselves wrong. The moment they find that they can't get the negative work, they find work negative, but they mark themselves wrong. They cancel it. And we'll give them an opportunity to come and redo the subject. In case they were not on the good network when DDK was teaching. Negative 89.4. Kilojoules per kg. Okay? So, what is our power?
402.3 kilowatt.
402.3. So this turbine at this point, it was never developing power. It was consuming in power. And how can you tell that was consuming? Hello?
Yes, sir.
How can you tell that power was going into the system? Number one, increase in internal energy. Number two, increase in pressure. And even as we have said that this is a compression line, are we together?
Yes.
For you to compress a gas, does it mean you are doing work on a gas or the gas is doing work on you?
We are doing work on the gas.
Exactly. So this, in any case, this is not a turbine, this is a compressor. But the question will come the way it came to confuse the enemy. There is also an increase in velocity. Have you seen that? So for velocity to increase, it means we are doing work. For pressure to increase, it means we are adding. Internal energy to increase, it means we are adding heat. Hello?
Yes, sir.
Erota waraisala tuma bufi wa Douglas Kavier ni mkutu mendaramu.
Apateni hapa. I'll just say it direct, sir.
Thank you. We end here.
Right.
Let's meet in the evening for strength of materials. I'll send you the questions just now so that you start working on them. You start looking at them.
All right, sir.
Thank you.
Thank you, sir.